The main purpose of this video is to give a short introduction to the concept of arctangent. So let's consider the tangent function. Notice that the tangent function has some vertical asymptote at x is equal to negative pi over 2, x is equal to pi over 2, and at every point of the type pi over 2 plus k pi where k is an integer, or negative pi over 2 plus k pi where k is an integer. So clearly from this graph, you can see that this function fails to pass the horizontal line test, so this function is not one-to-one. So it is not possible to define the inverse of the tangent function on the whole real line. What one has to do is do exactly what was done to define the square root function as the inverse of the restriction of the square function on the real line. So what we'll do here is to restrict the tangent function to the open interval negative pi over 2 to pi over 2. Notice that after this restriction, the graph of this function will pass the horizontal line test. So this restricted function on the interval negative pi over 2 to pi over 2 is one-to-one, and therefore it has an inverse function. Now we'll be able to define the inverse of the restricted tangent function. So the inverse of the restricted tangent function is what is known as the arctangent function. So we define arctangent of x to be equal to the angle theta if and only if theta is an angle which is in between negative pi over 2 to pi over 2, with the additional condition that tangent of theta is equal to x. Notice that it is really important for theta to be in the interval negative pi over 2 to pi over 2. Let us look at a concrete example. What is arctangent of 1? We claim that it is equal to pi over 4 for two reasons. First reason, pi over 4 is in the interval negative pi over 2 to pi over 2, and moreover, tangent of pi over 4 is equal to sine of pi over 4 over cosine of pi over 4, which is square root of 2 over 2 over square root of 2 over 2, and that is equal to 1. Here is another example. What is arctangent of square root of 3? That is equal to pi over 3 for two reasons. First reason is because pi over 3 is in the right interval, which is negative pi over 2 to pi over 2. And tangent of pi over 3 is equal to square root of 3. Notice that it is well possible to take an angle which is congruent with pi over 3, whose tangents will be equal to square root of 3, but arctangent of square root of 3 cannot be equal to that angle because that angle may not be in the right interval, which is negative pi over 2 to pi over 2. Now, if you understood this short introduction to the arctangent function, can you then guess what is arctangent of negative 1 over square root of 3?